Welcome all to our next tutorial on UltipaGraph. In this tutorial, we will look at how to query the various edges. We will look at the various samples one by one. The first sample is how to get the list of all the edges. So I go back here and run this particular query, find the edges as E and return E curly braces star, which means that get the list of all the edges in the current graph, irrespective of right now what type of edge it is, and return all their properties. So now when I run this is what I get. So I get the list of all the edges. These are the properties it has. One is the UID and another is the from property to property, and internally, right, the from node also will have UID and to property also will have UID. So those properties also listed. So besides the two properties that we created for the edges, which is the from and to, we will also have the UID, the unique identifier, and the from UID and to UID for the edges. This is what we observe using our first query result. The next query is, right, now I would like to get not all the edges, only the edges that belong to the category tube exists. So when I execute find edges and within parentheses, right, we give the curly braces and the name of the edge, which is the tube exists. So whenever we reference either a node or an edge, we'll always prefix with that symbol, and then we would like to return all the properties. These results will not be different because we only have one type of edge called the tube exists. Let me run the query again. So this is what we get next. We'll go to the query number 3. So now I would like to go and check what are the edges wherein the two properties equals 266. So this is what I do. Simply call the find edges method. Now write put the name of the edge, which is at tube exists. Then whatever property you want to check, you want to compare, put the dot and specify the name of the property. Now in this case 2. Right, that's the property I want to compare with the value called 266. So, and for any edge where the two properties equal to 266, I would like to get the from property, that is from which station the tube coming to station number 266. So from 350 it is coming, so that's the only result. Next we will go and look at the next query. Another type of comparison, just for demonstration purpose, right? So these are the various edges wherein right now the 2 is less than the number 11 symbol, mainly because it's the property 2 is defined as a character property, right? You have simply 101, 101, 103, 10 all getting listed, mainly because they all will come under alphabetically under 11, will be less than 11. So this is another reason why you have to be specific about the data types when you define the schema. This is what we understand from this particular query. We'll go to the next example. Now, right, in case if you have to make a comparison with multiple values, what we should do, something similar to the what we saw in the notes example. Here, right, we'll compare that particular property from against a list of values 26611. So any tube exists right now which starts from 26611, we'll get the list of edges. We will get all the properties mainly because we are calling E curly braces star curly brace. So these are the two tubes which starts from 26611 and they go to 326 and 177. Now I would like to get the list of all the from and to list. Okay, restricting myself to only the from property and to property, and also please note, right, I have defined edges as tube exists. So once I used the alias tube exists, I can use the tube exists dot from tube exists dot underscore 2, and this would actually give us more meaningful names because underlying the UQL, right, uses the generic face nodes and edges. So you feel free to always redefine the nodes and edges with the specific name that you want to use, so that the readability of the query is a lot better. So now I see two properties. One is the tubeexist.from and tubeexist.to. So you will see it in two tabs. So if we click on the tab under data underscore from, you will be able to see the list of edges here. And if it exists tubeexist dot underscore 2, you will see the list of nodes here. Now similarly, just like we were able to limit the number of nodes or edges limited to a specific number. Yeah, this is what I see. Now if you see, actually, even though we would like to retrieve all the edges that belong to the category to be exists, we would like to limit the result set to 3. So if we change the result set to 1, only 1. So let us try, what if we put limit 0? Yeah, so since the limit is set to 0, right, it doesn't return any result set. So next we will do the uncollect. Something, so this is exactly similar to what we saw in the nodes. So I put the uncollect 1 and 2, so that we treat this uncollect 1 and 2 as a collection of values. So it's like a for each loop in the programming languages. Once we use the uncollect as num in any query, right, it is like this particular portion of the query will be executed like a for each loop in other programming languages. So now what will happen is, for every value in num, right, this query will be executed. First time for the value 1 and second time for the value 2, and every time the results will be returned. So if we run this, right, so from 1 and 2, right, we are getting, so from edge now node number 1 we have a tube connecting to 281, and from node number 2 we have a tube connecting to 339. Okay, yeah, this completes the list of queries with which you can understand how to retrieve the various edges and their properties. Thank you.